Good morning, chemistry students. It is Wednesday, around 8 a.m. right now. We are going to be going over electron configurations today. Just a quick reminder, if you have any questions whatsoever, nball@steelacademyedu.org. If you watch the video, can you do me a favor? Just throw a like on it or something like that, just so I know that you've seen it. This one is going to be reviewing a little bit of electron configurations. It's something we got into a little bit, but we didn't really dig into the deep, hard stuff of it. So we're going to be talking about what it means to have the core of a noble gas, as well as s and p orbitals. All right, so moving on now. The first thing we're going to talk about is the s and p orbital. So I want to show you guys something you're familiar with. That's fluorine right there. Fluorine, it's one column away from being a noble gas. So you'll see it has those 7 valence electrons in the outer shell. The first electron level has only its 2, just like it's supposed to. But then we have full orbitals except for the last p orbital. You'll see on the top there, everything on the top here, I'll give you a little better view of this. Everything on the top is an s orbital, All the side sites that are added in the second electron level and beyond, they're called p orbitals. So to start off, let's go with something simpler than fluorine. Let's talk about helium. Helium's in the first row. Its atomic number's 2, so that means it has 2 electrons when it's not an ion. So something as simpler as helium, it only has 2 electrons. Both of those are in the s orbital, because you can see right here, it's at the top. Very, very tippy top. Because of that, we can actually talk about where the electrons are and where we expect them to be with its electron configuration, which is something new, but it's not that difficult. We should be able to translate showing where our electrons are with our electron shells into this quite easily. So because those are 2 electrons in the first energy level, we're going to put a 1. We know they're in the s orbital because they're up top. So we put an s. And you see that 2, it looks like an exponent here. That's just how we show it. Because there are 2 electrons there, we put a 2. So it's 1s2. All right, now to go to something a little bit more in depth, which you've seen already. This fluorine. An atom of fluorine, you'll see it has 7 valence electrons. But first, let's talk about that inside shell. That inside shell is a 1s2, so that's going to be involved there. If you've ever heard me say the core of helium or the core of a noble gas, I've been trying to build up to this point for you guys so that you're familiar with that terminology. That terminology is going to tell you that just like 1s2, core of helium means the exact same thing. That way you don't have to, once we get to the longer ones, you don't have to write it all out. But you know that if you can do the actual electron configuration for helium, it's fine to put core of helium. I know exactly what you're talking about. So that takes care of the 1s2. Then we have up top here, in the second energy level, 2s2s. So then we look 2s2. Then we see our p orbitals, which are these 3 around here. 1, 2, 3. And in the p orbitals, we have 1, 2, 3, 4, 5 electrons in the p orbitals. So it's as simple as something as 2p5. So these 2 answers here are both correct. 1s2, 2s2, 2p5, or core of helium, 2s2, 2p5. I hope that helps answer a couple questions and introduce this to you effectively. The book is a little tough on the reading for this, but if you have any questions, I'll be reaching out to you guys. Feel free to reach out to me. Once again, my email and ball@steelacademyedu.org. And I hope you guys are having a good day. Stay safe, social distance, do your best to protect the people around you, all right? And thank you for your time. That's the video for the day.